All right, next we're going to look at combining events with the word and. So if you took Math 97 at any point, we talk a lot about sets in Math 97, and we talk about intersections and unions. We also talk about complements, which is in the last section as well. The word and is usually interpreted to mean intersection. Right, so the intersection of A and B. Right. We use an upside down U, so there's our notation for intersection, is a set containing all elements that are in common to both set A and B. So if we look at this little image here, if one of these is set A, one of these is set B, they intersect, right? They overlap in this middle area. When we're calculating our probabilities, just a little note here, the probability of our intersection should always be less than or equal to our probability of B, and our probability of our intersection should always be less than or equal to our probability of B as well. So if we look at the probability of our intersection, it should be less than our entire probability of either event individually. So a Venn diagram shows information about 6 people. Suppose we were to select a random person. What is the probability that the person is wearing a hat and glasses? Right, so here we have a circle representing a hat. Here we have a circle representing the people wearing glasses, the people wearing both. Right, there's our and. So 2 out of 1, 2, 3, 4, 5, 6 people total reduces to 1/3, or 0.333 repeating, or 33.3%. Right, so our intersection is the people in the middle here. Again, this probability is less than if we took the whole group wearing hats, 3 out of 6, or the whole group wearing glasses, 4 out of 6. So there is our probability of H and G happening. All right, so let's do another kind of a little bit more sophisticated example here. These types of tables of information are going to be something that you're going to commonly run into as we go through this section and the next section. So feeling comfortable with these is something that you want to get used to. So the table below shows the education and marital status for 665 randomly selected people. Suppose we select a person at random. Note, less high school or less HS means did not graduate high school. So what we see here, along the left, we see education levels. So they did not graduate high school, they graduated high school, college or higher. And then along the top, we see marital status. So single, married, divorced, and widow or widower. Right? So then what we're going to look at here is we're going to calculate some different probabilities. Right? So the probability, the first one for A, what is the probability that the person is married? All right, so if we look at this, the total number of people that are married are 408. So we're going to take 408 divided by our sample space. Our sample space is the 665. All right, so we're going to divide this out using a calculator. I'm going to round to 3 decimal places. That's going to give us 0.614 or 61.4%. Again, depending on the problem, you may be asked to leave your answer as a fraction, write it as a reduced fraction. You may be asked to write it as a decimal or as a percent. So just kind of make sure you're listening to the instructions when you're going through and working on the homework. Right, what is the probability that the person has a college education or higher? So a college education or higher, we have 143. Right, so we're going to take 143 out of 665. 143 divided by 665 is 0.215 or 21.5%. And then part C, what is the probability that the person is married and has a college education or higher? Right, so we're looking at an and. We're looking at our table. Right, this row is our college education or higher. This column is our married. So we've got 98 that are both married and has a college education or higher. So 98 divided by 665, that gives us 0.147 or 14.7%. So another case of our and probability. Again, a little more sophisticated than just looking at our basic simple Venn diagram. Again, we're looking for people that fall into both categories. And notice that our probability of the and is smaller than our answers for either A or B.